Hey there, welcome to The Witch's Tech. I'm Lachelle Foley. Today we're going to be talking about the installer account and the programs directory. This is kind of a thing of mine. There are some similar procedures that are in place in some places, but generally not in Linux or Unix. And the reason I know this is when I'm trying to train somebody new to work within my system's ecosystem, they have no idea why I would do this or what's going on, and they start telling me how it's usually done. And and honestly, I appreciate people thinking and questioning authority and all, so I'm not complaining about that. But that is how I know that whatever this is, it's different from what other people do. But it does make a lot of sense, and I want to explain why and then exactly what's going on because I think that is useful. And also, as you watch these videos, you will see this in use, which means then you will have a chance of understanding it. First, though, a too long didn't watch. If the normal viewers will bear with me for a moment, this might be useful to you later if you have to come back and look at it, or it would be useful for any systems people who happen across. What's going on here is I am treating the user software differently from the system software, trying to separate them at least as much as I can. The user software gets installed using a non-privileged user. I call that user installer. And importantly, the software is installed into a location that is not on any of root's paths. I put that in /programs. And just don't ever give root a reason to go there under normal circumstances. I'll talk about why I landed on this as a way of doing things. It does have security and system stability implications, so I'll talk a little bit about those right now. What this is not going to do is it's not going to stop your user space malware. So it's not going to stop one of your users from installing a crypto miner in their own local space. It's not going to stop mistakeware. So people who either have buggy code or maybe they did something on purpose that just wasn't a great idea. It's not going to stop them from doing that either. But what it will do is contain the damage that can be done by that. So what it's going to help with is maintaining your system's operational integrity, so at least the core systems will still function so that you can do something about the other stuff. It will also help to prevent privilege escalation, so it's a lot less likely that the malware or mistakeware is going to end up being run as root or helping someone to become root. So I just talked about things that really are about security, but the original motivation was not security at all. It really happened in a time when, there were viruses, but it wasn't the big deal that it is right now. I had an entirely different population in mind when I devised the system, and that was scientists. And before anybody complains, I am a scientist. That's what I do. And, anything that I'm saying here, I'm saying about myself. I'm the one who made a lot of the first mistakes. And if it wasn't me, it was someone who was dear to my heart, someone I really liked. Or maybe I used some old code that, just was written before there was any idea of viruses or such like. So let's talk a little bit about the motivation a little more in terms of what scientists do. The first thing is they tend not to be malicious. They don't want to mess up anything, especially they don't want to mess up the computer that is going to run their software to do their science. They just want to do science, and they're not trying to mess anything up. But there are some other characteristics that are important. They are comfortable with being clueless, and that is not throwing shade. That is a requirement of the job. If you are doing science, You're doing something that no one else has ever done before. That's the point. You're adding new knowledge to the knowledge in the world. So you don't know what's going to happen, and no one else knows what's going to happen. And you have to carry on anyway. And we get really comfortable with that. And we also tend to be tinkerers because in order to do our science, we might have to learn lots of weird things that you might not expect, like vacuum technology or how electrics work or whatever. So we're comfortable with that. We're tinkerers. And so we're writing software. And at this point, usually someone will say, well, why don't you just hire a professional programmer, a professional software developer to write your code for you? And, there are times when that is really a realistic thing. So the job that I have right now, what I do right now, there's a team and we have professional software developers. We have professional systems people and they have to learn a little bit of science, but we try to protect them as much as possible from learning too much of the science. Anyway, yeah, there are times when that's appropriate. We've got sort of a big thing that we're trying to do for lots of people and lots of people use our services online. But what I'm talking about here, like the motivation for this was about your average scientist who's just got an idea and they're trying to figure out if a theory works and they're working on the code and they'll write something, oh, that didn't quite work. Let me mess with the math a little and change it. Does this theory work better than that theory? And they'll code it in. This is not a situation where a professional programmer is really practical. It's so much easier for the scientists to learn enough software to get their ideas down into some sort of logic that they can run. That's a lot easier than trying to explain the science that usually it took the scientists years and years to learn. Explain enough science so that a professional programmer will be comfortable writing the code. I mean, it costs a lot of money, if nothing else, right? So it tends not to be all that practical for that to happen. Usually the logic that the scientist needs in programming terms is relatively simple. Math. Math is the easiest thing to program. So simple. Like, that's the easiest thing I ever have to do programming. Oh, math, no problem. So anyway, the stuff you think of as hard, it really isn't hard to program. So anyway, on top of all of that, scientists, our safe space, our home turf is dense, technical, jargony text. We can read your documentation, and then we'll try to write software. What could possibly go wrong, right? And lots of things could go wrong, and some of you who know a lot about systems probably have begun to guess some of those things. But before we get to what can actually happen, let's talk a little bit about the software on your computer and how things work. So first I want to talk about users and privileges. On most Unix and Linux type systems, there is a root user, and this user is automatically generated. It is required. It is necessary for the functioning of the computer. Root is also God. Root can do anything. Root can run any program. Root can stop any program. Root can delete any files, add any files, even if what root's going to do is going to be bad for the system. Root can still do it. This is one of the reasons that we encourage people to have other users that are not root, because, I have all the power all the time is really dangerous. So you want to have another user that doesn't have so much power, that does most things day to day. You have to explicitly add those. They are not required for the system to function, but they are recommended. And they can only control their data. They cannot touch anything that is owned by root, and they can't touch anything that's owned by other users. They can only touch their own unless the other user or root says it's okay. The software on your computer most likely has some sort of file system like this, and that slash right there at the top, that means this is the root directory. For people who use Windows, that's kind of like the C drive. It's, where all the main software is installed. Mac OS now is based on Unix, so you've got a root directory. And yeah, that probably covers most people. All of those, everything under the slash, those are some of the most common directories that are at that top level. All of the red ones contain or are likely to contain software that is critical to the functioning of your computer. Users can read and they can execute things that are in those red directories, but they can't write to them, and that's good. They do have a space where they can read and write, and it's in a directory called home/home. Root can go into the home directory, usually doesn't, but sometimes has reasons to go into the home directories. Each user has their own home directory, and they cannot write into each other's directories. Another thing to understand is the idea of a path. This is how your system finds things. So if you want to tell your system, run LibreOffice, your system has to figure out where LibreOffice is. So you have something called a path, and a path is a collection of directories. And those are the directories that your computer goes and searches for software that you might want to run. So it's going to go to the first directory and say, is LibreOffice here? And if it is, it runs it. And if not, it goes to the second directory. It looks and eventually it finds it or it doesn't. But if it finds it, it runs it. Importantly, it finds the first one that it runs. So I want to look now at the two paths that are listed there. The first one is the default path for root on my personal system. The second one is the default path for a user, in this case, installer. This is the default path for installer. In gray is what is common between root and installer. So most of the path is common between root and installer, except that installer has some games tacked on at the bottom that are generally not very important in terms of what we're talking about today. I don't want to disparage any gamers. Anyway, so at the very, very front of the whole list, are two directories that start with user local. User local are directories that contain software that was installed outside of the main operating system. So this is software that you installed on your computer locally, and therefore it's considered more important and it gets run first. What I like to do is not have any user software in there. And I'll talk probably more about that in a moment. But so that, like the first one, user local sbin, that's the user space, local computer, super user binaries. That's the first one. The next one is user local bin. So in the user space, the local computer, the binaries. So if someone has dropped a malicious LibreOffice somehow into user local bin, that's the one the computer is going to run. It's not going to run the one that's in user bin, which is probably where LibreOffice is, and I haven't looked, sorry, but it's going to find the first one. So one of the things that I change is installer has a path put on the very front, and that's /program/bin. So installer and actually any other users on the system that are not root, they get this prepended /program/bin. And I put anything that might be just unknown, even not necessarily dangerous, but just I don't know enough about it. I don't have time to, search through all 10,000 lines of code and look to see if there's something malicious. Well, okay, I've got a sandbox. There's a little safe space I can put things, or safer space. Stick them in programs bin. And yes, they get found, but not by root. So to sort of say that again, what we're trying to avoid is we don't want root to install malware or mistakeware into your system, so in, say, the bin directory. And we don't want, even if we're going to say, okay, let's let installer, let's let some other user own user local and they'll install stuff down in there. Well, that doesn't help us because root still looks in that directory. And even if it's an unprivileged user who installed it, well, root comes along and runs it, and now root can do anything that code told root to do. So I like to not have anything that doesn't have to be root show up in any of those directories. So to say some of that again, the first protection is the user installer. So this is a regular user that installs user code. This user is just normal user, nothing else special. I did sort of first see this with scientific software. I was installing some software and it would not let me do it as root. It said, "You're root. Sorry, not going to install." So I got upset at first. I thought, I have to make a new user and install this software as this new user. Why can't I just be root? But I was kind of new at the whole dealing with a bunch of scientists system thing. And as I learned about my own code and code from others and code that came out of journal articles and copied in, I began to really get it. This was a scientific software company that understood that scientists are doing things on the cutting edge and they sometimes cut themselves. And we try not to let them cut other people, right? So anyway, um, the point is not to have anything accidentally get clobbered. You can't have your scientists overwrite some really important thing in the system because they're not allowed to write there. You do want this installer user not to be an existing user. So I don't want it to be Lachelle, my Lachelle user that's installing the software. It's going to be separate user installer. And I do that because installer cannot write into Lachelle's directory. So if installer is installing something sort of malicious, it might mess up installer's directory, but it's going to be less likely to mess up my directory. The last characteristic is that the only job of installer is to install user space software. That's it. Doesn't do anything else. I do have in emergency situations a couple of things that I let installer do. That's not part of this video, but pretty much. And there's no reason that you can't just say installer only, install software, nothing else. And I do call this special user installer for obvious reasons. Although on some computers, if they have special functions, I might use a different term if it just makes sense to do that. The second protection is the programs directory, so /programs. This directory is owned by installer, but it is treated as a system path. So for installer and for any user that is not root or not some other important user that I need to protect, it's just a part of the path. First thing in the path, /program/bin. Installer can put anything down in the programs directory. Other users, just like anything else on the system, other users can read what's in there and they can execute the programs, but they cannot write into the programs directory. Importantly, none of this is ever in any of root's paths. So I talked already about why not to use an existing directory, such as user local or /opt. The problem there is that these have been in use long enough that it's likely that these things will end up in root's path by something that gets installed, and for legitimate reasons. I'm not saying it's wrong for that to happen. I'm saying I wanted to make a space where, okay, this is the protected space. Root doesn't go here. So my installation rules are: root should install software if it is necessary for the system's functions. So drivers, system code, what makes your Wi-Fi work and talks to your keyboard and decides how to distribute memory and when to kill some process that is behaving inappropriately. Let root do this. I allow root to install things if it is installed via the operating systems package manager, such as apt for apt get this or apt install this or yum install or emerge or whatever it is, and whatever system it is that you're using, they'll have different names. But if it's part of the operating system to install the software, it's okay with me usually if root installs it. I would also be perfectly fine if root didn't even install that. Like if that were just installed by a separate user, that would be great. Installer installs anything else. So if you're downloading it, if you're compiling it, whatever, installer installs it unless it's a driver. If you download a driver to run your Wi-Fi, yes, root has to install that. But anything else, installer installs it. The exceptions: users can install code for themselves into their home directories if they really want to, and if they are writing code that makes sense. But I tend to recommend letting installer do it anyway. So that's the end of that explanation. Relatively short, I hope. Hi there. Hello. Sorry, but security recommends that you not enter this area. Okay.